Hi guys, what's up? In the series of Discrete Mathematics, today we are going to study some logical equivalences of quantifiers and how to validate quantifiers. So let's get started. Here are some logical equivalences involving quantifiers. First is universal quantifiers is distributive over conjunction, that is it is equivalent to for all x of px and for all x of qx. Existential quantifiers are distributive over disjunction, that is, there exists some x for px disjunction qx it is equivalent to there exists some x of px or there exists some x for qx. Universal quantifiers is only one-way distributive over conjunction, which are for all of x of px or for all of x qx. It is equivalent to px and qx. Px or qx. The reverse of this is not true. And the last point is existential quantifier is only one-way distributive over conjunction, which are there exists some x px conjunction qx is equivalent to there exists some x of px conjunction there exists some x of qx. Here in this slide we had to check the validity of predicates. Here validity of predicates is sure if it is a tautology. For finding if a predicate is valid or not, we had to use tree method. For understanding how tree method work, you have to see my previous video. So let's get started with this question. First we have to take negation of our entire predicate. After taking negation, we have to reduce this predicate into a conjunctive normal form. For this we use A implies B to negation of A or B. Therefore we got negation of after this negation get inside, then we have now we have to put the object in the place of x from universe of disclosure. That is, we take an example of p which is in the universe of disclosure, so that our equation become a of p and b of p and negation of ax u negation of b, sorry it is p. Now we have to make tree of it. For making tree, the parent node is the single sum term in our conjunctive normal form. So we place AP and BP at the top of the tree, and then we have to make child of it, which are negation of. The child of it are the sum term which contain two or more element, which is this. So we place negation A of P here and negation of B P here. You can see here A of P is closed by negation of P and B of P is closed by negation of BP. So our this statement is valid or sure, or it is a tautology. Now let's take another example. Here first we take negation of the whole predicate. After taking the negation, we simplify the inner equation. After this step, the outer negation come into under and cancel out the first negation. Here we get and because of the negation, and here we have negation for all of x. A of x. After this, these two negation get inside and convert for all into their exist. And when we have a term like for all of x, ax or bx, then when we distribute for all x, in the place of x from universe of disclosure, we have to use two variables for it. For example, here we have to write a of p v and here we have only a single term of p. Now we have a conjunctive normal form and we have to make a tree for it. So we first take the single sum term which are negation AP and negation BQ. And then we have to make two child of it. So here we take this sum term and write it here AP and BP here. Now here you can see that negation of AP and AP close each other, so this branch is closed. but this branch is open. So now we take this sum term. So here we write AQ and BQ. So you can see it here, negation of BQ and BQ close each other. So this branch is closed, but this branch is not closed. This is an open branch. So this predicate is not valid. So friends, if you find this video helpful, please like, comment and share this video with your friends. And don't forget to give your feedback and subscribe to my channel. Thank you. See you next time.